Hello everyone. In this video we're going to discuss how to create this frozen lake inside Unreal Engine 5.7. We have two layers. One is the top layer, the another one is the depth layer. You can see. Okay, so this is what we are going to create today. Okay, let's get started. First we are going to create a material. So right click, material, open up this. So select the material. I'm going to change the blend mode from opaque to translucent color transmittance. The next, in the translucency, we're going to change the lighting mode into surface forward shading. For this material, I'm going to create a substrate. So right click and search for the slab. So you can create the substrate slab. So connect this into front material. Okay. For the diffuse, I'm going to right click, promote to parameter. For the F0, which is a specular reflection, I'm going to create a scalar parameter, hold S and left click. Specular, by default, I'm going to give 0.25. Connect this into F0. And I'm going to duplicate this. F2, rename this. It is a Fresnel effect. So I'll give the value, default value 1. Connect this into F90. Roughness, right click on the roughness, promote to parameter. Okay. Now I can see this reflective material. I'm going to save this. Right click, create metal instance. Assign this into the flow. Now you can see the reflective material. Next, we are going to create subsurface scattering mean free path. To do that, so right click, search for mean free path. So you get this substrate transmittance to mean free path. Just create. Take this MFP into SSS MFP. Now immediately you see this is showing this is a opaque material which does not have any translucency. If you want to make a subsurface scattering, it should be a translucency. So select this substrate material, go to subsurface type, change this from diffusion to simple volume. Now this is a translucent. Now we can able to see the translucent material. For the transmittance color, I can right click, promote to parameter, and thickness also, right click on the thickness, promote to parameter. Take the output thickness to SSS MFP scale. Now we get this translucency. Now I can go to this material, select this floor, and I'm going to open this metal instance, double click to open. I'm going to enable this all. And I want to enable this transmittance color. Just open the transmittance color. I'm going to increase it. Also, I wanted to increase the thickness. Now we can start seeing this subsurface scattering is happening. You can change the color if you want. Okay. Fine. If I increase the roughness, you get that blurred reflection, right? So this is going to be the top layer of the frozen lake. But I want to create a depth, right? To create a depth, I'm going to create a parallax occlusion mapping, which is a material function. For this function, we need a height map. Okay. For the height map, I have this material downloaded from the Quixel Megascan, which is having this height map, displacement map. So if I open up this ORDP, this is a channel packed texture, which means each channel have a different texture. Red is the ambient occlusion, green is the roughness, and the blue is the displacement. This displacement we are going to use for create the depth. So take this texture, drop into the material. We cannot take this blue directly and connect into the height map because this needs a texture object. This is a texture sample, right? So right click on this and convert to texture object. So this is become a texture object. I cannot mask only the blue channel from this texture object, but I can connect directly all the channels into height map texture. But if you want to filter only the blue, you can use this height map channel vector 4. So I'm going to click 4 and left click. So I can create a vector 4. This I'm going to change the blue into 1 so that the vector 4 is a blue. I'm going to take this RGBA and connect into height map channel 4. This will filter out only the blue channel from this texture object. Okay. So next, right click on the height ratio, promote to parameter. Right click on the max steps, promote to parameter. Right click on the reference plane, promote to parameter. Now we have all. Instead of using this color, I'm going to use the same ORDP and drag and drop into this. Take this parallax UV and connect into UVs. I'm going to take this blue channel and connect into diffuse albedo. Now if I save this, I will not see anything, just go to the, so I'm going to reduce the thickness. Now you can start seeing this displacement texture is visible. Okay, so I'm going to enable this height ratio. I'm going to increase it. Now you can see the height. So this height ratio will define how much depth you want to create. But this is not a high quality. So you can increase the max steps to get the proper looking depth. Okay, now you can see the depth. We can able to see, right? I can increase the specularity a little bit so I can see the specular reflection is happening. I'm going to reduce the roughness to 0, so now I can see the reflection is happening. So now we have 2 layers with the depth, right? Now I'm going to create a top layer. The top layer, I want to create a frozen lake texture. I have this frozen lake texture, so I can take this albedo texture into frozen material and drop it inside. Okay, so directly I'm going to multiply this both, hold M and left click, take this blue into B, take this RGB into A, connect this output into diffuse albedo. Now save this. Now you can see the top layer, we have this, the bottom layer, you see the depth is coming out. You see that? We have this illusion, right? So for that, because I have to adjust this reference plane, if I increase it, you can see this is going below, right? We can move this down. We can offset the displacement up or down. Okay. I can adjust the height ratio. You can see this is calculating only the depth. Next, I'm going to create a roughness. Roughness, instead of directly connecting this parameter into roughness, I'm going to create a texture because I want to create roughness texture. And this material have this channel pack. Just drag and drop this ORDP inside. Okay. The green is the roughness. I'm going to hold L and create the linear interpolation. Take the green into alpha. The alpha is going to define the reflection. So I'm going to create a roughness. I'm going to disconnect this roughness. I rename this minimum roughness. Duplicate. F2. This is going to be max roughness. By default, I give 1. Okay. Take the minimum into A. Maximum. Take the maximum into B. Take this output into roughness. Save this. Now you can see this, you're getting this nice frozen lake effect. The roughness gives the illusion. Still, I have the option to control this min and max roughness. Minimum is 0, the maximum roughness is 1. If I can reduce it, you get more reflection. I can adjust the thickness. Now you can see this, the light is scattered inside. I want to reduce the specularity a little bit. And I'm going to create a normal map. So we can take this normal map, drag and drop inside. Take this RGB, connect into normal. You can see the normals. This reference plane will offset the height. How much you want depth. You can see the depth. If you want to make some color tint on this, I can use another color here. So you can use multiply. Take this into B. We have already this diffuse albedo. I'm going to use this into A and connect this into diffuse albedo. Save this. Now you see that this is completely opaque now. So I'm going to enable this diffuse albedo. I'm going to make this white. Now slowly you can see, I can change the color if you want. I can make even more color tint. Okay. You can see so this transparency is depending upon this thickness because the light is scattering inside. So you can see, you see this edges looking very bright. That is because the specular Fresnel, if I make it 0, this is completely dark, right? So if I enable that, you get the Fresnel effect on the edge. So this is really good. If I look directly from here, you can see through this. If I rotate the camera, and this looks like the scattering is not visible. This is very, very useful. Looks very natural. Now you see this pattern is visible. I wanted to increase the tile for the depth. So I can create this UV. To create the UV, first I want to use a UV coordinate. Hold U and left click and create multiply. Hold M and left click. Right click on the B. I'm going to promote a parameter. So I will call this UV tile. Okay. I leave this one by default. Connect this into UVs and save. I have the UV tile, so I can reduce it or increase. See, I am adjusting the scale of this. I have to adjust the reference plane. You can adjust the depth. Okay. Next, I have some assets from Megascan. I can drop this inside, increase the scale. You can see this, I have created this all. I'm going to change the exponential fog. Just select the exponential height fog. I'm going to adjust the fog height fallout. I'm going to reduce it. Go to sky atmosphere. Go to sky atmosphere. I'm going to change this MIE absorption scale. Increase this. You can see the blue tint you get, which gives a nice snow environment. Right click and play. You can see this. One final step I'm going to do. You see this, the depth is not so clearly visible, but you can able to control this. Let's go to frozen lake material. You see this color transmittance, we are directly connecting to the transmittance color. I'm going to multiply this with this blue color. So hold M and left click. Connect this into B. Take the blue channel from this and connect into A. Connect this into transmittance color. So now we can clearly see the snow inside. Get this specular reflection.